Hello, today we're going to take a look at lesson 8.4, which is rational expressions. We're going to focus in on multiplying and dividing today, and then in 8.5 lesson, we're going to add in addition and subtraction. So to start off with, I just want to focus in on simplifying, then we'll add in the multiplication and division. So for this section, we're going to really focus in on factoring. So to start off with, we take our A times our C, which multiplies to 10. So we need to figure out what multiplies to 10 but adds up to this middle term 7. So we'd have the 2 and the 5. They both need to be positive. So we put x plus 2 times x plus 5. Then we go to our denominator. We take our A times our C, which is negative 10. So we still have the same combination, but now it has to add up to negative 3. So we'd have negative 5 and a positive 2. So x plus 2 and then x minus 5. Then from there, if anything is the same and it's in factored form, then we can cancel them out from top and bottom. So the x plus 2's are the same, we can cancel those out. So we have x plus 5 divided by x minus 5 left over. We can't reduce those because one's positive and one's negative. So that would be our final answer. And then from there, it is going to ask us what restrictions do we have, so we would say x cannot equal negative 2 and x cannot equal 5. And how we get those, we set the denominators equal to 0 and solve for them. So we go to this next one. We have 24x to the third y squared divided by negative 6x squared y to the third. This one we cannot factor, so we're going to start canceling right away. And we can because it is a multiplication problem. Up here, notice they were adding and subtracting on top, adding and subtracting on bottom, so we cannot cancel out. We had to wait until it was a multiplication problem before we could cancel out. This is already a multiplication problem, so we can start reducing. So 24 divided by negative 6, we can divide both of those by negative 6 and just get negative 4. So we'd have negative 4 in the numerator. We're reducing that fraction. We have 3 x's on top, 2 x's on bottom, so 2 of them cancel out and we're left with 1 on top. And then we have 2 y's on top, 3 y's on bottom, 2 of them cancel out and we're left with 1 y in the denominator. So that would be our reduced final answer. And then from there, we're still going to set what's in the denominator equal to 0. If we set this negative 6 equals 0, there's no variable with it, so we can't solve for it. We set this next one, x squared equals 0, so we just get x equals 0. And then y cubed equals 0, so we just get y equals 0. So those are our two restrictions, x and y cannot equal 0. Now let's get into the multiplication problems. So we have this multiplication problem. We want to go ahead and start off with factoring everything that we can. So that's x minus 5 in the denominator, doesn't factor, so we just leave it. But on top we have x squared plus 1x minus 6. We take our 1 times our negative 6, we get negative 6. We need to figure out what multiplies to negative 6, but adds up to this middle term 1. So we would have a positive 3 and a negative 2. It multiplies to negative 6, adds up to 1, so we throw that combination in. And then over here we have the difference between two perfect squares. So we take the square root of 25, which is 5, so x plus 5 and x minus 5. And then in the denominator, we need to take our a times our c. We get 3, so we need to figure out what multiplies to 3 and adds up to 4. So 1 and 3, so we plug that combination in. Once we get it, we need to think of the rules of multiplication. Multiplication is top times top, bottom times bottom. So we're going to make this a big division bar, and we're multiplying all of these on top, all of these on bottom, so top times top, bottom times bottom. Now with it being a big division bar, I want you to think of it like problem number 1. Anything that's the same on top and bottom, we can cancel those out. So it doesn't matter if they're directly on top of, or one's over here and one's down here. But as long as all of this is on top, all of this is on bottom, if it's the same, then we can cancel those out. So x minus 5 and x minus 5, we can cancel those out. X plus 3 and x plus 3, we can cancel those out. Nothing else is the same, so we then are left with what's left over as our final answer. And then from there, we want to find our restrictions. So we set each of the denominators. It doesn't matter if we canceled them out or not, but we set them equal to 0 and solve for them. So we'd get x minus 5 equals 0, so x cannot equal 5. X plus 3 equals 0, so we solve for it. We get x equals negative 3, so then that's our restriction. And then set this one equal to 0, we get negative 1, so x cannot equal negative 1. And each of those are making the denominators equal 0. So positive 5 minus 5 is 0, and we can't divide by 0. So those are why there are our restrictions. For number 2, we want to go ahead and factor everything. A 2 goes into both of these, so we can factor out the greatest common factor of 2, and then we have x minus 4 left over. This is the difference between two perfect squares, so the square root of 16 is 4, so we have x plus 4 and x minus 4. We take our a times our c on this one, we get 4, so we're figuring out what multiplies to 4 adds up to 5, so we have 1 and 4 as our combination. This one we take 1 times 16, we need to figure out what multiplies to 16, but adds up to 8, so we get 4 and 4, so we plug that in. And then it's a multiplication problem, so think top times top, bottom times bottom, so we make this a big division bar, and whatever is the same on top and bottom, we can start canceling out. So the x minus 4's cancel out. One of these x plus 4's can cancel out, and that is it. So what is left over is our answer. So 2 times this x plus 1 divided by x plus 4 and x plus 4. And then from here, we want to set the denominators equal to 0 to get our restrictions. So we get positive 4 here, negative 4 here, negative 4, and negative 4. So x cannot equal positive 4, and x cannot equal negative 4. Now for division, we want to make it a multiplication problem. So if you think how you divide fractions, you keep, change, and flip. So you keep the first fraction, you change it to multiplication sign, and then you flip the second fraction. So we still want to go through and factor everything, but we want to remember to flip the second one. So I always make this arrow on the second fraction so I remember to do so. So for this first one, notice how it kind of just looks backwards. The variable is second instead of first. So I'm going to rewrite it as negative x plus 2. Then from there, I want to factor out a negative 1, so my x term is positive. So I'm going to have negative 1 and then switch both of those signs to the opposite. So negative 1 times x minus 2. So that is my factored form. And then down here I'm going to factor, so I see what multiplies to 1 but adds up to 2, so 1 and 1. So I plug that in. And then I'm going to switch this to a multiplication problem and then flip these. So x squared minus 1, I'm going to factor that, and that goes on top. So I have x plus 1 and x minus 1 because it's the difference between two perfect squares. And then I'm going to factor this, so I take my 1 times my 10. I need to figure out what multiplies to 10 but adds up to 3, so this 2 and 5. So then I plug that down here because I needed to flip my second fraction. And then now it's a multiplication problem, so I make that a big division bar. Anything that is the exact same on top and bottom, now I can cancel out. So x minus 2 is cancel, the x plus 1's cancel. Nothing else is the exact same, so what is left over is my answer. So that negative 1, don't forget about it, that x minus 1, that x plus 1, and that x plus 5. And then I need to set each of my denominators equal to 0 to solve for them, and that will give me my restrictions. So x cannot equal negative 1, x cannot equal negative 1, x cannot equal negative 5, and x cannot equal positive 2. This next one, I have x squared plus 5x plus 4 divided by x squared plus 1x minus 12. So I want to go ahead again and factor each of these. So I take my 1 times my 4, I need to figure out what multiplies to 4 but adds up to 5. So 1 and 4, so I plug those in. And then I take my 1 times my negative 12, I need to figure out what multiplies to negative 12 but adds up to 1. So I'd have 4 and negative 3, so I plug that in. Then this part is going to go to the denominator. It's the difference between two perfect squares, so I have x plus 1 and x minus 1. Then this part has a greatest common factor, so I can factor out a 2x out of both of those. And when I divide both of those by 2x, then I have x minus 3 left over. Or if I distribute now, I get back to what I started with. So I could only factor out the greatest common factor on that one. Now that I have it factored, and I already switched the top and bottom, now it's a multiplication sign. So I go ahead and make this a big division bar, and whatever is the same on top and bottom, I can start canceling out. So the x plus 1, cancel out. The x plus 4's cancel out. The x minus 3's cancel out. So I'm left with this 2x divided by x minus 1, and that is my final answer. And then from there, I set each of these denominators equal to 0, and that would give me my restrictions. So I get x cannot equal negative 4, x cannot equal positive 3, x cannot equal positive 1, and x cannot equal a negative 1. Now for the division ones, And I just forgot to talk about this on this last one, but we'll go back up to it. Notice how this was originally in the numerator, then it got switched to the denominator. So we have to set both on the second fraction, the numerator and the denominator equal to 0 for our restrictions, because at one time or another, they're both in the denominator. So we'd have to set this 2x equal to 0, solve for it, and we get x cannot equal 0 then, and this x cannot equal 3. So we have it. If we go back up to this one, set this numerator equal to 0, we get positive 1, and this one we get the negative 1. So make sure in division problems for the restrictions you set both the numerator and the denominator of the second fraction equal to 0, because at one time or another they are in the denominator.